And so then we're going to ask a bunch of questions about this velocity. The first one is, when is the particle moving to the right? And when is it moving to the left? Okay, so how do I figure out when the particle is moving to the right? Yes, Al? When the velocity is positive, exactly. If the velocity is positive, it's moving to the right, and if the velocity is negative, it's moving to the left. So I need to figure out when the velocity is positive. So here's my velocity equation. So if I set it greater than 0, then I'm figuring out when it's positive, and thus I'm figuring out when it's moving to the right. So then this involves solving an inequality. And solving an inequality isn't super easy. So what's the first step for solving an inequality? Good, set it equal to 0 and undefined, because that's when it might switch from positive to negative. Set it equal to 0 and set it equal to undefined. In this particular example, it's never undefined. So we don't need to worry about that on this example. But we do need to figure out when it's 0. To solve for 0, you just divide by the 6. So then we're trying to figure out when the sign of a mess is 0. So we want the sign of 3t. We can just think of that as one thing temporarily. The sign of something equals 0. So now we're going to look at the unit circle. And at the point 1, 0, and at the point negative 1, 0, at those two locations, the sign is 0, right? Why is the sign 0 there? Yeah, the y value is 0, right? Okay, so those angles are 0 and pi and 2 pi and 3 pi and 4 pi. So that means we need this mess to be maybe pi, right? Because if that whole circled mess was pi, then we'd be taking the sign of pi, which would come out to 0. So if that whole circled mess was 0 or pi or 2 pi or 3 pi, et cetera, then we'd end up taking the sign of one of those, which would come out to 0. Madison, you all right? You seemed a little unsure about that.
Could you explain that one more time?
So if this circled mess was replaced by pi, then I'd be taking the sign of pi, which would come out to 0.
Right.
So that's why I want the whole circled mess to be pi,
Okay.
or those other things.
Got it.
Good. And then to solve for t, you just divide the 3 away, right? So 0 divided by 3 is 0. Pi divided by 3 is pi over 3. 2 pi divided by 3 is 2 pi over 3. So you divide them all by 3, right? Now, wait a second. Why didn't I cross out this pi? It's out of range, isn't it? Isn't the range supposed to just be 0 to pi over 2? Well, the reason I didn't cross out that pi, even though it's out of range, this is not, right? It's the final answer that needs to fall in between 0 and pi over 2. So I don't want to cross out too early. Now here, I want to get rid of that because that's out of range, right? And here, that's bigger than pi over 2, so I'm going to cross that out. But wait till the final answer until you start crossing stuff out. Okay, so now we've got 0 and pi over 3. Okay, so then you put those on a number line. Well, those being the 1. Sometimes there's more than 1, right? Because pi over 3 is where this quantity might switch. So now we need to test to see if it actually does switch there. Whenever you solve inequalities, the first step, set it equal to 0 and undefined. But then after that, test the intervals to see where it's positive, where it's negative. Okay, so now we need something in between 0 and pi over 3. So pi over 4 would be a good representative. So I'm going to plug that into my equation, 6 times the sine of 3 times pi over 4. Three times pi over 4 is 3 pi over 4, which is here, right? The sine of that is root 2 over 2. So this is 6 times root 2 over 2, which comes out to 3 root 2. Which is positive. So everybody sure they know what's going on? Are you positive that you understand? Oh, it's good to be back. All weekend. Well, actually, it was the same. Nobody laughed at my jokes over the weekend either, so it doesn't matter to me. I tell bad jokes everywhere. Nobody laughs everywhere. It's all good. But seriously, is everybody okay with this? Okay. All right, so now I need a representative between pi over 3 and pi over 2. So I've been trying really hard to make this a completely non-calculator problem, but I think here that's going to fall apart. Because here, pi over 3 is pretty close to 1. Pi over 2 is pretty close to 1.5. So I need something between 1 and 1.5. So I'm going to go with 1.2. So that's 6 times the sine of 3 times 1.2. 3 times 1.2 is 3.6. The sine of that is something, times 6 is something. If I remember right from last period, it's negative 2.655, but somebody better check me on that. So it's negative, right? In between that interval, pi over 3 and pi over 2, this quantity, velocity quantity, is going to be negative. Okay, so now finally we're ready to answer the question. The question was, when is the particle moving to the right? So when is the particle moving to the right? On the interval 0 to pi over 3. Okay, so particle is moving right on the interval 0 to pi over 3. And the particle is moving left on.
So if we're talking about when it's moving right and when it's moving left, when it is at pi over 3, shouldn't that be a parenthesis?
Yeah. I mean,
Technically it's not moving.
no, maybe it is moving then. Maybe it paused and then went on. And then, yeah. I'll put parentheses in and then I'll argue with it later. Parentheses are certainly fine. Yes, I agree. It's not a big deal. See what he's saying? He's saying the velocity is 0 there, so it's not moving there. Sort of. But how can you not move for an instant? But again, we don't want to get into it. I agree. Parentheses are better. I give it. It's hard for me. As you know, it's hard for me. But I'm admitting it. Everybody good? For part A? Okay, so now for part B. If S of 0 is 9, what is the final position? If f of 0 is 9, what is the final position? Okay, so we've been doing a lot of integrals recently. And so sometimes it's tempting just to automatically find an integral without thinking about why. So let's just pause for a second. We're going to take an integral on this problem. But the reason we're going to take an integral is we have the velocity graph, which is in meters per second. An integral is an area. So if we found the area on this graph, I'm going to make some numbers up, right? Let's pretend that the height was 5 meters per second. And let's pretend the width was 2 seconds. So if you go 5 meters per second for 2 seconds, you end up traveling 10 meters. So the area on the velocity graph has something to do with distance. Because 5 meters per second times 2 seconds is 10 meters. Okay, so if I'm looking for my final position, I want to find the area on the velocity graph. But that'll just tell me, as long as the velocity is positive, that'll tell me how far I went, right? But I don't want to know how far I went. I want to know where I was. So I need to add in my starting position. If I take my starting position plus this, that's going to give me my final position. So yeah, good point, Carter. That's the plus C, right? That we always have to include. Okay, so this is how we're going to figure out our final position. So then, how do you calculate this? Yes, what was that? You put it in your calculator, right. Okay, let's say it's unfortunate and it's the non-calculated part of the test. Then how do you calculate it? You have to take the antiderivative of this. Okay, so now next step is to work on the antiderivative of this. So we've got our 9 plus, then we're going to take the antiderivative. So the 6 is just hanging out, because it's a constant. Doesn't affect the antiderivative. The antiderivative of sine is negative cosine, because the derivative of cosine would be negative sine. So if we wanted to get positive sine for our derivative, we need an extra negative hanging out to cancel out for that other negative that's going to pop up. And then of 3t, right? Now, this is pretty darn close to the correct answer for the antiderivative, but it's not quite right. So, if you get an antiderivative, how can you check to see if you're right? Take the derivative of it, right? If you take the derivative of this, if it's the correct antiderivative, we better get that. So let's go off to the side and take the derivative of this. Okay, so the derivative of that would be negative 6 hanging out. Derivative of cosine is negative sine. But then what? Times 3 from chain rule, right? So the derivative of what we have written down is actually this, not what we want. but it's only off by that 3, right? So how could we get rid of that 3? Multiply by a third or divide by 3, right? So if we take this and multiply by a third, I mean the whole thing by a third, not just the 3t, right? So it's going to end up being -2. So, yeah.
Would it be appropriate to start with that for every chain rule, or?
You can, yeah, if you want. So this is really the only brand new thing today. This 1/3. It's not super hard. The other stuff is hard, and so that's why we're going over it again. But this is the brand new thing. So is everybody clear on why this 1/3 is popping up here? It's backwards chain rule. Because when I take the derivative of this, an extra 3 pops out. So I can get rid of that extra 3 by timesing by a third. Okay, so now I need to evaluate that from 0 to pi over 2. Okay, so when I find an area, when I calculate an integral, first step is antiderivative. Then what? Plug stuff in and subtract, right? Plug pi over 2 in, plug 0 in, and subtract. While I do that, I'm just going to make that -2. So I've got 9 plus -2 times the cosine of 3 times pi over 2 minus -2 times the cosine of 3 times 0. So plug in pi over 2, plug in 0, and subtract. So then 3 times pi over 2 is 3 pi over 2. Cosine of 3 pi over 2 is 0. -2 times 0 is 0. Why don't I go ahead and make this plus, because minus a negative. Cosine of 0, 3 times 0 is 0. Cosine of 0 is 1. -2 times 1 is 2. -2 minus a -2 is plus 2. So final answer is 11. What would the label be? 11 meters. And that means what?
That was the final position.
It was the final position, not the total distance, but the final position. So I started at 9 on my, I started at meter marker 9, and now at the end I'm at meter marker 11. It's the final position. AKA S of pi over 2 is 11. Yes?
I'm just kind of wondering here, if you had just like a, instead of a velocity per time graph, you just had a position per time graph, you took the derivative of it, wouldn't it still be distance?
No.
Well, okay. Well,
If you took the antiderivative of a position time graph, you would be taking meters times seconds. And so you'd get meter seconds, which doesn't really have an application often. Now, with pounds and feet, the foot pound had an application. But a meter second doesn't generally have a meaning. Good. Yeah.
Can you just calculate the final position by plugging S of pi over 2?
Yes. So we could have found the antiderivative of this, put down a plus c, figured out the c using S of 0 equals 9, and then we could have plugged in pi over 2. Yes, that would be an alternate way to do this problem. And it's a great way to do this problem. It's just in chapter 7, we try to think of Well, that is S of x, isn't it? The sly S of x. Plug a pi over 2 there. So we are plugging pi over 2 into S of x. Good. But yes, then you can get the S function explicitly if you want, which is what you were saying. But we're just trying to expand our horizons into this kind of a formula rather than explicit formula. Awesome question, George. Okay, let's see, that was B. We're on to part C now, which is find the displacement. Okay, so what is displacement? How far you are from where you started, right? So one way to calculate it is to figure out your ending position and then figure out your starting position and then subtract. We just found out the ending position, right? It's 11. We know the starting position, it's 9. So we know that this answer is 2. The particle started out at 9, ended up at 11, so the displacement is 2. But again, I want to put a different spin on it. Doesn't the fundamental theorem of calculus say that this is equal to this?
From interruption, please. I need Cheyenne Wolfenbarger to sign up for the attendance office, please.
She is not in this class. So this is equal to this, right? The fundamental theorem of calculus says to calculate this, you find S and then subtract two things, right? So these are equal to each other, right? So this is the displacement. So another way to think about displacement is it's the integral underneath the velocity. That's the area underneath the velocity. And we already calculated this over here, right? The work is right here. It just leave out the 9 and we did the work, right? So the displacement is 2. Another way to think about it. We already knew the answer was 2, but I wanted you to think about it in terms of an integral. Because then if you have a calculator like Rebecca hopes, then this is easier than this, right? You just type in math 9, velocity 0 pi over 2, and you're done. You don't even have to think. So it's good to know this formula in addition to that formula. Displacement is 2 meters, right? Okay, then part D is going to be find the total distance traveled. Okay, so for the total distance traveled, the problem is this particle, it started at 9 and it ended up at 11, but it might not have gone straight there. Maybe it went that way and then came back to 11. Or maybe it went this way past 11 and then back, right? So we didn't find total distance traveled here. We just found displacement. Started at 9, ended up at 11. So its displacement is 2. What did happen to the particle? Did it go straight to 11? How do we know that it didn't go straight to 11? Yeah, Zach? in part A, we found out that the velocity was positive for a while, and then the velocity was negative. So in part A, we found out that it started at 9, went this way past 11, and then had a negative velocity to come back to 11. So it traveled more than 2 meters. So to find the total distance traveled, this is how you calculated it. Because what was happening in this integral without the absolute value was the positive velocity was canceling out with some of the negative journey, and that's why we were only getting 2. But now if we take the absolute value of all those velocities, then we'll be counting all of the journey as positive, and thus we'll be counting all of the distances. So if you have a calculator, just pop that into your calculator with the absolute value sign. It's under Math 9. But if you don't, then we need to know how to calculate this, right? Okay, if the velocity is positive, I can just drop the absolute value sign. When is the velocity positive? 0 to pi over 3. So I can go from 0 to pi over 3 here and just get rid of the absolute value sign. Because the absolute value doesn't do anything to a positive number. And we found out in part A that that velocity was positive during that part of the time interval. Okay, but then from pi over 3 to pi over 2, it's a little trickier. Because from pi over 3 to pi over 2, the velocity is negative. And I don't know how to take the antiderivative of an absolute value. So I need to somehow get rid of those absolute values. But I can't just drop them. What I need is something that'll take a negative number and make it positive. So what'll do that, Dan? If I multiply that negative number by -1, it'll transform it to a positive number just like absolute value would. So I'm going to take -1 times my velocity. And it looks like I'm making the velocity negative, but in fact I'm making it positive, right? Because it's already negative, and then that negative times that negative comes out to positive. Yes, sir?
Was one of our rules for integrals that we could flip the pi over 2 and pi over 3?
Yeah, so Carter's saying if I wanted to get rid of this negative sign, I could flip these. And then it would be a negative of another negative, and good. Okay, so now I'm going to take the antiderivative of v of t, which I already did, luckily. That was -2 times the cosine of 3t, right? So now I'm going to just bring this negative out in front of the integral and make it a minus. Okay, so this is -2 times the cosine of 3 times pi over 3 minus -2 times the cosine of 3 times 0. That's the first integral, right? minus negative 2 times the cosine of 3 times pi over 2 minus negative 2 times the cosine of 3 times pi over 3. Everybody doing okay? Okay, so now 3 times pi over 3 is pi. Cosine of pi is negative 1. Negative 2 times negative 1 is 2. Cosine of 0 is 1. 2 times 1 is 2. Cosine of 3 pi over 2 is 0. Cosine of pi is negative 1. Times negative 2 is positive 2. Still doing okay? Even with the unit circle stuff? I know you need practice on that, so practice it now. Yeah. Here. So in my head, I changed this to plus a positive, but then the cosine of pi was negative 1. And so then that 2 times negative 1 came out to minus 2 again. Good. Yeah, so that was hard because there were 3 negatives in a row, which came back to positive. Everybody else good? Okay, so then this is 4. Minus negative 2, so 6. So 6 meters is the total distance traveled. Okay, so here's what was going on picture-wise. Here's my velocity graph. The velocity was positive from 0 to pi over 3. But then the velocity was negative from pi over 3 to pi over 2. That's what we found out in part A, right? Velocity positive, then velocity negative. Then I took my area under my velocity curve from 0 to pi over 3, and I got 4. And then I took my area from pi over 3 to pi over 2, and I got negative 2, right? But since I was doing total distance traveled, I wanted to count that negative 2 as positive. So that's why I took the opposite of it. And that's why I ended up with 6 meters total distance traveled. But when I did the displacement, that 4 was canceling out with some of that negative 2. And that's why I ended up with 2 for my integral of just plain velocity. Everybody okay on this picture? Okay. So that was example 1. Example 2 is not as long. Let's say you had a velocity graph. And you had miles per hour over here. Because we've been doing velocity in meters per second, but you could do velocity in miles per hour. And on the other hand, let's say you had seconds down here. So that's a little bit awkward, because per hour and seconds aren't matching up. But if the question said find the distance or the displacement, you would find the area underneath the velocity curve, just like we have been doing. Okay, so let's pretend that the area was a rectangle. Let's say it was 900 tall. So what does that mean? 900 miles an hour, right? So it's whatever's traveling is traveling pretty fast, 900 miles an hour. And let's say it was 30 wide. So what does that mean if it's 30 wide? For 30 seconds. So whatever's traveling 900 miles per hour does it for 30 seconds. So to find distance, then you take the rate 900 miles per hour, multiplied by the time, 30 seconds. And when you multiply that out, you get 27,000. What's a mile times a second? A mile second, right? A foot times a pound is a foot pound. A newton times a meter is a newton meter, so a mile times a second is a mile second per hour. So you could say to the person they traveled 27,000 miles seconds per hour. And they'd say, what? I don't know what that is. So now we need to convert this. This is distance because it's velocity times time, right? It's just got a label on it that we don't understand. So we're going to convert this. How many seconds in an hour?
60 minutes.
60 seconds in a minute, right? Times 60 minutes in an hour. So 3,600 seconds per hour. So if I write it like that, I'm wrong, right? Because my dimensional analysis, nothing's going to cross out. So I want 1 hour, 36,000 seconds. So now my seconds will cross out and my hours will cross out, right? So I get 7.5 miles. So what does that mean? If something goes 900 miles an hour for 30 seconds, it ends up going 7.5 miles. Okay, then to make matters worse, the problem that I'm trying to help you on wants the answer in feet. So now we got to multiply that by 5,280 feet in 1 mile. And you better check me on this. I'm just trying to remember from an hour ago. I got a lot of, I don't know if you can tell, but I got a fair amount of sleep over the weekend. That's why I'm able to remember everything from an hour ago. That's why I'm like more animated than even normal. 39,600 feet. So that's like space shuttle thing, right? If the space shuttle takes off and it's going really fast, it goes to that tall, 39,000 feet in about 30 seconds. That's about right. Okay, so there's a problem where you need this to convert like this, so that's why I'm helping you with that. It's not calculus. Okay, the only brand new thing today was that new antiderivative. So let's practice a couple of those real quick here. So what's the antiderivative of the cosine of 7x? Should it be negative? Shouldn't be negative because the derivative of sine is cosine. So the antiderivative of cosine is sine. We're doing antiderivative, so this is a sine, right? Okay, is this 100% right? No, because if you took the derivative of this, an extra 7 would pop out, right? So how do I compensate that? Multiply by a 7th, right? Okay, how about the antiderivative of e to the x over 4 power? This is sort of right, because the derivative of e to the x is e to the x, right? Except an extra 1/4 would pop out, right? So you multiply by 4 to compensate. This is backwards chain rule, right? antiderivative of chain rule problems. That's the only brand new thing from today, so that's why we practiced a couple. Everybody okay? So in the daylight problem, the derivative, an extra 2 pi over 365 popped out, right? So then when you did the antiderivative, which you didn't have to do because you could do math 9, but if you did the antiderivative, an extra 365 over 2 pi to compensate for the 2 pi over 365, right? Everybody okay?